Hypothesis testing is a process where we use our sample data to help draw an inference or conclusion about the population. We have to form two hypotheses, a null hypothesis and an alternative hypothesis. The null hypothesis is the status quo, or there is no change. The alternative hypothesis, HA, is an alternative claim about the value of a parameter. There are three possible forms of hypotheses for a test for mu, and even for p. We have a right-tailed test where we have an increase. We have a left-tailed test where we have a decrease. And we have a two-tailed test where we only know that there was a change. When you want to state the hypothesis, we have a strategy. So you need to find what the problem is telling you. You need to determine the form of the hypothesis and figure out the corresponding symbol. And then you need to find the value of your mu0. A result is statistically significant if it is unlikely to have occurred due to chance. And so here's an example. An invasive species discharged from the ballast tanks of transoceanic ships are a growing problem in the Great Lakes. The round goby is an invasive species that carries the parasite Neochasmus umbellus. A 2007 study reported that the mean intensity, or the mean number of parasites per infected host, was 7.2 parasites. Scientists worry that the population mean number of parasites in the round goby has increased since 2007 and want to test that hypothesis. Our null hypothesis is that the parasites have stayed the same, so mu equals 7.2. Since this is a right-tailed test because they say increased, the alternative hypothesis is that mu is greater than 7.2. The mean annual rainfall in Arizona has been 8 inches per year according to the World Almanac. Weather researchers want to know if this already small amount is going to decrease, leading to a drought. Write a null hypothesis and an alternative hypothesis that describe this situation. So you want to search the problem for key terms. Decrease is a key term, so we need to use the less than, so it's a left-tailed test. So here is how we would form our hypothesis. Now, when we're doing this, we are prone to type 1 and type 2 errors. A type 1 error is when we reject the null hypothesis and it turns out to be true. And a type 2 error is when we keep the null hypothesis and it turns out to be false. Alright, this decision that we're making when we keep or reject the null hypothesis is not proof. It's just saying that there's a statistically significant change. Our probability of a type 1 error is our alpha. Yeah, I'll just cut that out. Alright, when we talk hypothesis testing, we have two methods. We're talking the critical value method and the p-value method. You're going to learn that for both mu and the population proportion p. In the next videos, no, just cut it out. We'll just keep going and cut it up. I hate recording. The z-test for the population mean mu, critical value method, okay? So when the observed value of x bar is unusual or extreme in the sampling distribution of x bar, that assumes, the sampling distribution assumes that, give it a minute so I have some nice cut points. Alright. Nope, do not say alright so. Now we're going to talk about the critical value method for the z-test for the population mean mu. When the observed value of x bar is unusual or extreme in a sampling distribution of x bar that assumes the null hypothesis is true, we should reject HO, otherwise we shouldn't. The critical region consists of the range of values of the test statistic for which we reject. The non-critical region consists of the range of values that the test statistic z data for which we don't reject the null hypothesis. The value of z that separates the critical region from the non-critical region is called the critical value, and that will be notated as z crit. So here are the steps for doing a hypothesis test. First, you need to state the hypothesis, so you need to determine if your problem is left-tailed, right-tailed, or two-tailed. Then you need to find your test statistic and your critical value. The test statistic formula is x bar minus the mean of mu0 divided by the standard deviation of the population, also divided by the square root of the size. Given the level of significance in your calculations, you need to follow a rejection rule. And then you interpret the results. When you reject, you say there's evidence of level of significance alpha that whatever your alternative hypothesis says. And when you accept, then there is evidence at level of significance alpha that whatever your HO says. Now, this makes no sense unless you have an example in front of you. But here is the critical value method table that you need to follow for this. It gives you your level of significance. Okay, so if my alpha is 0.1 or I have a 90% confidence interval, then my z-crit for a right-tailed is 1.28. My z-crit for a left-tailed is negative 1.28. And if I have a two-tailed, it's 1.645. Same thing for a 0.05 alpha and a 0.01 alpha. Here is our rejection rule for the critical value method. In a right-tailed test, if our z data is greater than or equal to our z-crit, then we reject the null hypothesis. If our z data is less than or equal to our z-crit in a left-tailed test, we'll reject the null hypothesis. And one of the two things can happen in a two-tailed. Either our z data is less than or equal to the negative of our z-crit, or our z data is greater than or equal to our z-crit. That would reject our null hypothesis. So here's an example of a right-tailed test. According to Facebook.com, the mean number of community pages, groups, and events that users are connected to is 80. A random sample of 64 Facebook users showed a mean of 86 connections to community pages, groups, and events. Assume the standard deviation equals 48. Test using level of significance 0.05 whether the population mean number of connections to the community pages, groups, and events is greater than 80. Since that's greater, we're going to do a right-tailed test. And a random sample of 64 Facebook users showed a mean of 86 connections to community pages, groups, and events. So N is 64. Assume that the standard deviation of the population is 48. And we want to test using level of significance 0.05. So alpha equals 0.05. Whether the population mean number of connections to the community pages, groups, and events is greater than 80. This is a right-tailed test because we want to see an increase. We started at 80, we sampled at 86. We want to see if we have a statistically significant difference. So let's go back to our form for forming our hypothesis. This is a right-tailed test, so our hypothesis is going to look like this. Okay? So, I'm going to go write that down. Our hypothesis is H0 mu equals 80. HA is that our mu has increased from 80. Now I need to calculate our test statistic. We should figure out our crit first, our z-crit. We're dealing level of significance 0.05, so our z-crit is 1.645. Now I need to calculate my z-data. So I know that that's 86 minus 80 divided by 48 over the square root of 64. So 6 over 48 divided by 8. 6 over 6, that's 1. So now let's look and see what our rejection rule was. Our rejection rule for a right-tailed test is that our z-data is greater than or equal to our z-crit. Our z-data is not greater than or equal to our z-crit. Z-data is not greater than or equal to z-crit. So we are going to keep the null hypothesis. So when we want to interpret that, we need to say there is evidence at level of significance 0.05 that the mean is still 80. Okay? And that's how you would interpret that.